Hello friends, welcome to this third session on numerical analysis series. In this session, I would like to solve a couple of examples based on numerical differentiation formulae which we have derived in the previous session. So before going to solve the problems on numerical differentiation formulae, let us recall the two important formulae which we have derived in the previous session. So first, when we want to find the derivative of the function f, that is, if we want to find f dash at the point x0, that is x0 is the initial point. The formula is going to be quite simple in this particular case because it is the special case. As a special case, we have derived this particular formula. We have discussed it in detail in the previous session. Please have a look at that session. Now we will be using this particular formula to solve the numerical examples. So what is the formula in fact? Formula is to find the value of f dash at the point x0. X is equal to x0, that is the initial point, and the formula is very simple, 1 divided by h. So h here is the step size. H is very easy. How to find h? H is the difference between two consecutive values of x. For example, x1 minus x0, or x2 minus x1, and so on so forth. If you consider the difference between two consecutive values of x, that is the step size and the notation is h. So we will be using that over here, and in the bracket we are having these terms. Please have a look at these terms. First order difference of f at x naught, and it is minus half, minus 1 by 2 into delta square f at x naught, 1 by 3 into delta cube f x naught minus c. The formula, if you remember, it is there is a simple technique you can have. How the coefficients are, you please look at the coefficients. 1 here, the coefficient is just a minute. Here the coefficient is 1. Here the coefficient is half. Here it was 1. Here it is half. Here it is 1 by 3, 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6. So these are the coefficients and the signs, positive or negative. First term start with positive and alternatively negative, positive, negative, positive, negative, positive, and so on so forth. So this is the technique. You can use it to remember the formula very easily. The first term is having the first order difference, that is delta 1. Delta 1. The second term is delta square. When it is delta square, its denominator will be 2. When it is delta cube, its denominator will be 3. When it is delta 4, its denominator will be 4. Like that, you can have a very simple technique to remember the formula. So this formula we will be using to find the derivative of f at x naught, that is the first order derivative. And now the second order derivative. Second order derivative is equal to 1 by h square. That is f double dash at x naught is 1 by h square into the bracket. The coefficients you have to by heart the coefficients, or you can use your own technique to remember. So how to remember? The terms will start from second order derivatives. This is the second order derivative we are finding, and here the terms will have the second order differences. Delta square, it starts with delta square f at x naught. Everywhere it is f at x naught, f at x naught, f at x naught, f at x naught, f at x naught. Everywhere it is f at x naught. That is only the leading differences we will be considering. And now the first one will be delta square, as I have told you. While finding f double dash, while finding the second order derivative, we will be having the second order difference starting, and then third order difference, fourth order difference, fifth order difference, sixth order difference, and so on so forth. And again start with plus sign, then minus, plus, minus, plus, minus, plus, like that it goes alternatively. And the coefficients, Here the first two terms are having the coefficient 1, the third one is 11 by 2, the fourth one is 5 by 6, the fifth one is 137 by 180. So these three terms you have to by heart, or by your own style you can memorize the things, and that is the required formula for finding the second order derivative of the given function f at the initial point xr, that is. So with the background of these two important formulae, that is this formula, the formula number 1 and the formula number 2, we will now move on to solve the examples. So let us consider the first example. I have told you already in the introduction class itself, the most important aspect of numerical differentiation is that we are going to find the derivatives of the dependent variable y with respect to x one time and two times. There is a first order derivative and the second order derivative. Even we don't know the that is the explicit definition of the function. Even without knowing the definition of the function, we can find the derivative of the function involved. And the thing is that we should have this table of values. This is very important. We should have this table of values of x corresponding to the discrete set of values of y. So with this table of values of x, we can now move on to find the derivative of the given function y at the initial point 0. So this is the initial point, this is x naught. So at this x naught we are moving to find the derivatives. There is a first order derivative and the second order derivative. The thing is very simple. The two formulae we are having, here are the two formulae. These two formulae we will be using. X naught is 0. We have in this table, from this table, x naught is 0 and x1 is 1, x2 is 2, x3 is 3, x4 is 4, x5 is 5, and corresponding to them y0 is 4, or f of x0, you can call it as f of x0, f of x1, f of x2, like that. So this is the table we are having, and if we look at the formula, we require the differences, the first order difference, the second order difference, the third order difference, fourth order difference, and so on so forth. At the initial point only we need, that is only the leading differences we will be looking at. So therefore we are supposed to find the differences. How to find the differences? It is very simple task. To find the differences, we shall use this data and we will construct the forward difference table. How to construct the forward difference table? It is very simple technique, very simple thing. What should we do? We should write down these two values in the vertical direction. X values in the first column, y values in the second column. I will show you how that happens. So this is the table we are having over here. Please have a look at this. So here if you look at this, first of all, the values of x which we have written in the first column are 0, 1, 2, 3, 4, and here it is 5. So these are the values of x given. Corresponding to the values, these values of x, the corresponding values of y are, if you look at the table, you will come to know 4, 8, 15, 7, 6, 2. So the same values 4, 8, 15, 7, 6, 2, the values have been written in the vertical direction. Now you forget about this, we don't have to do anything with this. Now we have to play with this second column. So how to proceed? To get the first order differences, that is delta f of x or delta y of x, what should we do? We should subtract this value from this value. That is, we have to consider 8 minus 4. 8 minus 4, answer is 4. You have to write down the answer in between, so that is very important. You have to use this style of writing. So where we are writing the answer here, that is this value 8 minus of 4, answer is 4, that is to be written in between these two in the next column, that is in the first order difference column. So now we will proceed further to get the other first order differences. So next will be 15 minus 8, the answer is 7, write it here. Next, 7 minus 15, answer is minus 8. 6 minus 7, answer is minus 1, and so on. 2 minus 6, answer is minus 4. So we have now obtained this column, and this column is of first order differences, that is delta values. And again, to get the second order differences, ಏನು ವಿಷಯಲು ಒಂದು 5 ನಿಮಿಷ, ನಾವು ಒಂದು 10 ನಿಮಿಷ ಮಾಡಿ. To get the second order differences, we have to use the first order differences here. So here, this value minus the upper value, that gives 3, that is the first second order difference, that is just like delta square of f at x naught, so that is 3. Similarly, minus 8 minus 7 is minus 15, I have written here. Minus 8 minus of minus 8, it is minus 1, plus 8 is plus 7. Minus 4 minus of minus 1, that is minus 4 plus 1, answer is minus 3. So likewise, we got all the values in the third column, that is for second order differences. So using the second order differences, these second order differences, we can move further to get the third order differences. Again, this minus this is here, this minus this is here, and this minus this is here. And once again, after getting the third order differences, we can proceed to find fourth order differences. So these are the two values we are having, and after getting the fourth order difference, we can proceed to find the next order difference, that is finally the fifth order difference, only single value, minus 72. So likewise, we can have this type of triangular table, and this table is called as the difference table. And using this difference table, in this difference table, what values are important? Only the leading differences, that is the differences which are present in this top level, they are to be used. This is a delta y, this is y at x0, that is f at x0. This is delta f at x0, this is delta square f at x0, this is delta cube f at x0, and so on and so forth. We will be using these values, and we can also come to know that what is the value of h here. You take the difference of any two values of x. 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1. So everywhere h is constant, because I have already told you in the beginning itself that NFIF, that is Newton's forward interpolation formula, by which we derived the earlier two important formulae of numerical differentiation, are valid only when the x values are equally spaced. So you can observe each value of x is placed at a regular interval h. So step size is h everywhere. So h here in this particular problem is 1. So here h is 1 and the initial point x0 is 0, and here y is in place of f of x. So we have the formula for formula in the formula with the notation is f of x. We have to understand that this f of x is nothing but y. So therefore, by using the same formula of first order derivative, this is the formula of first order derivative. I have written the formula once again here, and in this formula we have to substitute the known values. So h value is 1, that I have written over here 1 by 1. In this particular step you can observe f is replaced by y. The simple replacement of f with y I have shown you here in this particular step. So this is an intermediate step. You can omit this step also. You have an option so that you can reduce the number of steps. For your understanding, I have written over here. Now let us substitute the values. H value is 1. I have written over here delta y naught. So how to get delta y naught? The leading first order difference, the leading second order difference, the leading third order difference, the leading fourth order difference, the leading fifth order difference. So how to get them? We have to get them from the table. Leading means the top values, these values. So this 4 and 3 minus 18, 40 minus 72. So they are to be substituted here. 3 minus 18, 40, 72. Only delta fifth. So let us simplify these expression, these terms within the bracket, and this 1 by 1 is 1. So the thing becomes something like this. You can use the calculator and you can simplify this. You will come to know that the final answer on the right hand side is going to be minus 27.9, and that is the required value of the derivative of y at the initial point x0, that is y dash of 0, we have obtained. This is half of the solution we have completed, and now let us move on to find the second order derivative. To get the second order derivative, we have again the formula here. This is the formula which we have already seen in the beginning itself, and here delta square f at x naught is replaced by delta square y naught. Again delta cube f at x naught is replaced by this. So only the replacement is shown over here in this step. So again this is an optional step. You can omit it or you can write it for your understanding. And now the next step is to substitute the values of delta square y naught, delta cube y naught, delta fourth y naught, delta fifth y naught. They have to be obtained from the same difference table which we have already constructed in the beginning itself. The same difference table will give us the values of these things: delta square y naught, delta cube y naught, delta fourth y naught, delta fifth y naught. And by substituting these values in the formula becomes something like this. So these are the values which we have written from the difference table, and now it is the time to simplify. Here h square means 1 square as it is. Now the simplification of RHS looks like this, and when we simplify this RHS, we get the final answer, that is 117.67, and that is the value of the required second order derivative of y at the initial point x naught. So this completes the worked example on solving the evaluating the first order derivative of y at x naught and second order derivative of y at x naught. So I hope you understood very well how to differentiate, how to get the derivative of the given function that is up to the second order, that is the first order derivative and the second order derivative at the initial point x naught. With this, let me stop. Thank you very much. Once again, I request you people to look at this textbook and this is for your further reference. So with this, let me thank you all. See you in the next video.